Hello.
Hello.
Hi.
Yes,
Uh,
I can.
okay. So last class, where did we stop? You're looking at limits and all, right?
Yes, sir.
Uh, did I tell you anything about derivatives?
So
Yeah.
I think you started derivatives.
Yeah. And I told you that all the derivatives are one limit, right? This limit.
Uh, no, I don't think so.
This I did not say. Hmm?
No, sir. So
Okay.
you spoke about slope of tangent as derivative and
Hmm. Okay.
like how you
So
instead you have to take the slope of the chord like that and then.
okay. So 1 second. Just hold on. So there is a function like this, let's say, and you are at one point and here, right? Now, if you think about it, this is y-axis and this is x-axis. So the rate of change of the function between these 2 points, right? This point and this point, right? Let's say this
Yes.
is p and this is q. So the function value has gone from here to here, right?
Yes.
Okay, so rate of change of the function will be called, we talked about how this is an average rate of change, right?
Yes, sir.
So this average rate of change will be change in y by change in x, correct?
Yes, sir.
So this is the change in y and this is the change in x, right? So if I had to calculate, I would write change in y by change in x, which is the slope of this chord, right?
Yes,
Tan
sir.
theta. So tan theta is equal to change in y by change in x. Now, this is basically average rate of change over that interval from p to q. How fast is the function changing its value, right? Now,
Yes.
in case you want to find instantaneous rate of change, what you have to do is make that interval really small. Okay.
Yes, sir.
So make the interval really small. So how do you do that? You ensure that p becomes closer and closer to q, right?
Yes, sir.
Suppose you have a point here and a point here. This is p and this is q. You bring it closer to q, right? So
Yes.
if you bring it closer to q, you will notice that the chord will become smaller and smaller and smaller, and eventually it will look like the tangent line, right?
Yes, sir.
So this point and this point, now you are still going to find del y by del x, but what you are making is that x is tending to 0, del x is tending to 0, right?
Yes, sir.
So limit of del x tends to 0, this rate will become some value, and that will be the instantaneous rate of change of the function. Instantaneous rate of change of the function at p. At p.
Yes, sir.
So this is what your speedometer is doing. It is just doing it. It is actually not doing the limit part. It is doing a small time interval, right?
Yes, sir.
But what you have to do is make the time interval infinitely small. Okay. So what does this mean? So how can we write it in a different way? So if this point is x and this point is x plus h, right? So this function value is f of x plus h, and this function value is f of x, right?
Yes, sir.
So limit of, if you say h tends to 0, h tends to 0 means x plus h will tend to x only, right?
Yes, sir.
So limit of h tends to 0, change in the y value. Change in the y value is this value minus this value, f of x plus h,
Minus f of x.
f of x plus h minus f of x, and divided by change in the x value, which is h.
H.
So this ratio, and if you take the limit like this ratio becomes your derivative. This is the derivative of of fx at p. It is also, obviously, it is also the slope of the tangent to the curve at p, because this is very next, a point right next to x, right there. If you join these two, it is very close to a tangent line, right?
Yes, sir.
So same thing means tangent at P, slope of tangent at P, slope of tangent at P. Sometimes it is written as f dash of x also. Multiple ways to write it, but it means this limit. Okay.
Yes, sir.
So now, so if I ask you, find the derivative of x square, find the derivative of x square at x is equal to 3. Now, why don't you try it yourself and find out the derivative? Like, just follow the process. Okay, just now we learned what derivative is a limit, right?
Yes, sir.
So just calculate the limit for the function y is equal to x square. Okay, so what is the limit that we have to calculate? Limit of h tends to 0, f of x plus h minus f of x by h, right? This was called f dash of
Yes, sir.
x. Now think about it. For this particular case, you were at what point of the curve? Where were you taking the derivative? At x, right? The second point was x plus h, right?
Yes, sir.
And you are bringing this closer. So you are taking derivative right now at x is x, right? The variable point. So whatever answer comes from here, in this particular question, you have to put x is equal to 3 in that, right?
Yes, sir.
Because here you are taking derivative at a fixed point, no?
Yes, sir. Yes.
Correct. So, or, okay, fine, just do that. First find the derivative for a variable point x and then put x is equal to 3, right? So calculate this.
So it's 0.
How? Tell me how?
But then h can't be 0, right? Because the thing won't be defined.
How are you getting 0?
If you take x as 3,
No, don't take x as 3 right now. First find the value of this no limit. I'm asking you to first find the derivative for any x. When you get the answer, then put x is equal to 3. Any x, you understand, x is a variable point. It could be
yes, yes,
anywhere,
but
right? What is f of x plus h for this function?
I'm not sure.
What is the function?
Y equals x squared.
So what is f of x plus h? F of x is equal to what? X square.
Yes, sir.
What is f of x plus h?
X squared plus h.
X squared plus h. Okay, this is like a major issue. Have you read any part of calculus book that you saw?
Yes, I read it.
What part
Like,
have you read?
I read the limits part and the preliminary chapter, and I read a bit on derivatives also.
So, so in the derivative chapter, or before that in the preliminaries chapter, he taught to you about what is a function, right?
He explained what a function was, like the same thing you had told.
So if the function fx is called x square, what does the function fx do? It takes input what?
X
And gives output.
of x squared.
If you give input right now, what is the input here?
X plus h.
So what will be the output?
X plus h squared.
On what did you say earlier?
Sirs,
What did you say earlier? You said x square plus
x
h.
squared plus h, I think.
Is
Yes.
it the same thing? F of x plus h will be x plus h whole square, no?
Yes, sir. Yes.
Why are you saying x square plus h? You understand that it's a
Yes,
major
I
issue.
got the. I got it.
So this is x plus h whole square. minus f of x is what? X square by h, right?
Yes, sir.
So now find this out. How will you calculate this limit? You cannot put h is equal to 0, right? It is in
Yes,
the
sir.
denominator. So simplify it a little bit, this
So you
part.
can factorize it.
So it will
So
become what?
x plus h minus x into x plus h plus x.
So like this, divided by h, right?
Yes, sir.
Now what happens to h? It gets cancelled.
Yes, sir.
Now you can put h is tends to 0 there. What is left?
Yes, sir.
In this, if you put h tends to 0, it will become
2x.
2x. So this is the meaning that I want. F dash x has come out as 2x, right?
Yes, sir.
This means that the derivative is 2x. Now x can be any place. You can find now in general, derivative at x is equal to 3, 4, 5, 6, whatever, right?
Yes, sir.
So at f dash of 3 would be what? 6.
Yes, sir.
So what this tells you is that slope of the tangent to the y is equal to x square curve will be 6 at point x is equal to 3. Right?
Yes, sir.
Okay. See, that calculus and analytic geometry book, right?
Yes, sir.
I want you to attempt the exercises. Try the exercises of preliminaries chapter, the function section. Functions, there is a section at the end of that chapter, right? Functions.
Yes, sir.
And before that, there will be a section on modulus also, mod x, right?
There exercises in the middle also.
Yeah. There are exercises in the middle also, exercises at the end of the chapter also, right?
Yes, sir. So which ones do I do?
Do 5 questions from each exercise. 5 to 10 questions from every exercise. Because it feels like I don't think we can rush this part, because if you don't know this properly, then it will become a problem later.
Yes, sir. Okay.
So preliminaries chapter, limits chapter, every exercise 5-10 questions. Okay. And if you have any problem, you have to tell me.
Yes, sir.
We can do extra class to solve your problems. Okay. But you have to tell me. It is on you to take initiative and find out problems and figure out your stuff.
Yes, sir.
It is not my responsibility to force you, right? Correct?
Yes, sir.
So you have to do the limits, preliminaries, and the derivatives chapter. Derivatives chapter is chapter 2, I think. Right? Chapter
Yes, sir.
2 is derivatives, chapter 1 is limits, chapter 0 is this. And after that, we are going to discuss in today's class what we might reach the end of chapter 3 also. So whatever we have covered so far, you have to go through every exercise, do 5 questions, at least know what is going on, right?
Yes, sir.
So because otherwise this will become a problem. If you don't know calculus properly, at least conceptually you should know what to do. You should not be like I don't expect you to solve very difficult problems right now. I expect you to know what is going on. Okay.
Yes, sir.
Which is important. Then now we are going to find out the derivatives of several functions. So if you look at chapter 2 or 3 in HCV with the physics and mathematics chapter, he will have a table of derivatives in
Yes, sir.
that chapter. So the derivatives table that he has is, for example, first function he takes is y is equal to x power n, and he says dy by dx is equal to nx n minus 1, right?
Yes, sir.
So now we are going to derive this. So basically the idea is that all of the derivatives that you will encounter will obviously come from the same definition. You have to do the same thing in each derivative, right?
Yes, sir.
But later, when you are more comfortable with calculus, what will happen is that you will know the answer right away. You will not have to take the limit every time. Okay. So
Yes, sir.
later what we'll know is we'll know the results and we'll use the results and methods to differentiate.
Yes, sir.
Okay. So for now, let's do this one. find the derivative of y is equal to x power n at any general point x, right? So ultimately what we have to do is dy by dx we have to calculate when y is equal to x power n. So basically what do you have to do? You have to do limit of h tends to 0 f of x plus h minus f of x by h, right?
Yes, sir.
Now try it yourself once, see what happens.
So is it limit h tending to 0, x plus h whole power n minus x power n by h?
That only. But now calculating it is the part, right?
Yes, sir.
Are you facing some issues there?
I'm not sure how to like start.
X plus h to the power n minus x power n by h, right? So the problem is that this h you cannot put, you have to cancel it somehow, right? Just like it got cancelled in
Yes,
the
sir.
last one, right? But the problem is that you don't know how to expand this, right? So here you might have
Yes, sir.
heard of something called
Binomial
binomial
theorem.
theorem. Have you heard of it ever?
Yes, sir.
In Alan, they have told you, okay?
They haven't taught it, but like I've heard of it.
So basically, what is this binomial theorem? First of all, this is called a binomial because it has two terms, right? This is a binomial.
Yes, sir.
If it is a one term, it is a monomial. Otherwise, it's a trinomial and so on, right? And
Yes, sir.
you are raising it to the power n. So now you want a way to write the answer, okay? So I already know formulas if n was equal to 2 or n was equal to 3, right? I
Yes,
know
sir.
what it will be
Plus h
because
square.
I know these identities, right?
Yes, sir.
3xh x plus h, right? So I want to figure out what it will be for 4, 5, 6, whatever n, right? So basically you are multiplying it many times, right? Now, if you have heard of the Pascal's triangle, that will tell you what to do here. So 1, 1, 1. Have you heard of the Pascal's triangle?
Yes, sir.
So 1, 1, 1, 1, 2, 1. 1 3 3 1 1 4 6 4 1 1 5 10 10 5 1 and so on. You keep constructing by adding the upper two and making this addition to be 6, right? You
Yes,
see the
sir.
pattern of how you are adding, right? The first and last of each one is 1, and each term in between comes by the sum of the upper two terms to the left and to the right.
Yes, sir.
So 3 is coming because 1 plus 2, 2 plus 1 is also 3. 1 plus 3 is 4, 3 plus 3 is 6, and like this, right?
Yes, sir.
Now these terms are coefficients. So this is the coefficient of x plus y whole square. This is the coefficient of x plus y whole cube. This is the coefficient of x plus y whole 4. This is x plus y whole power 5. So notice that it is working out. See, 1,
Yes, sir.
2, 1, 1, 3,
3, 1.
3, 1, right? And so on, right?
Yes,
So
sir.
later when we do permutations and combinations, we'll learn many more things. But for now, I will just give you the formula here. What is happening is this is x power n plus n times x n minus 1 h plus n into n minus 1 by 1 into 2 x n minus 2 h square plus n into n minus 1 into n minus 2 by 1 into 2 into 3 x power n minus 3 h cube and so on. Basically these terms, these coefficients are basically called combinations, nc1, nc2, nc3 and so on. Now you might not have heard of those things right now. What is a combination? nc1 for example,
Like choosing
n factorial
one thing
out
out
of
of
n
n.
things. Yeah. Choosing one thing out of n different things, right?
Yes, sir.
So this is n factorial by n minus 1 factorial, 1 factorial. And the way you calculate factorial, I hope you know.
Yes, sir.
Factorial is n
N
into
into n
n
minus
minus 1
1
till
and till
1.
1.
And this is n minus 1 into n minus 2 till 1. And this is 1. 1 factorial. 1 factorial is 1 is equal to also 0 factorial by definition. Okay.
Yes, sir.
So this happens. So now everything you will cancel, no, every factor except n, right?
Yes, sir.
nc1 is n, nc2 let's do. So that is n factorial by n minus 2 factorial, 2 factorial. So that becomes n into n minus 1 into n minus 2 factorial, right, on top by n
Yes, sir.
minus 2 factorial into 2, right?
Yes, sir.
So everything gets cancelled here except these three terms, n into n minus 1 by 2, right? Now
Yes, sir.
similar, so basically the binomial theorem actually says something like this: x plus y power n will be equal to x power n plus nc1 x power n minus 1 into y power 1 plus nc2 x power n minus 2 into y square plus nc3 x power n minus 3 into y cube and so on, right? Plus ncn x power 0 into y power n, right?
Yes, sir.
Correct. So now using this, right? Using this now, try it out and see if you can figure out the x plus h power n minus x power n by h limit, right? You know how to write now this expansion, right? And you know how to calculate the values of this, right?
Yes, sir.
Correct. So follow this method. Whenever you have NCR, it will be n factorial by n minus r factorial into r factorial, right?
Yes, sir.
That is the definition of NCR, okay? And use that now to expand and get this limit. Try it out. I will be back in 2 minutes. I have to make a call, okay?
Okay, yes.
Just try it out yourself. Hello? Yeah. So are you getting anything here?
No, so I was trying, but
Yeah. So expand this, no, by binomial theorem. So if you expand it,
x
it
bar n
plus
plus
NC1
nc1 x bar n minus 1 and
uh,
h1
h power
plus
1
h bar 1 plus nc2.
and so on.
Yes, sir.
So on last term will be NCN x power 0 h
H
power
bar
n
n.
minus h power x power n minus x power n, right?
Yes, sir.
Divided by h. So now see that first term cancels, right? Right?
Yes, sir.
And notice that one h can cancel from everything, right?
Yes, sir.
So the expression that you get, this goes away. Denominator is no longer there. So expression that you get is nc1 x power n minus 1 plus nc2 x power n minus 2 into h power 1 now, right? Plus so on till ncn x power 0 h power n minus 1, right?
Yes, sir.
And now here you don't have a denominator h, so there is no problem in actually taking the limit now, right? Limit h tends to 0. Now notice that h tends to 0 ensures that every term other than the first term will become 0, right? All these terms become 0, no, because of the h present.
Yes, sir.
So everything disappears except first term. First term is what? nc1 was n only.
Yes, sir.
You understand? nc1 is n factorial by n minus 1 factorial into 1 factorial, right? So that
Yes,
is
sir.
simply n, because n into n minus 1 factorial is n factorial, right?
Yes, sir.
So this gets cancelled and this becomes n minus 1 factorial and that gets cancelled, right?
Yes, sir.
So what you have gotten is a very general result that if y is equal to x power n, then dy by dx is coming out to be n into x power n minus 1, right?
Yes, sir.
So this solves your problem for all powers of x. Now you can find out, no? So it's not like now you just have to know, you have to do separately for y is equal to x square and separately for x cube, right? You know that y is equal to x square, dy by dx will be, now apply the formula 2x power 2 minus 1, right?
Yes, sir.
2x, right?
Yes, sir.
And this one will become dy by dx will become equal to 3x power 3 minus 1. So 3x square, correct?
Yes, sir.
So that is a useful result because now any power of x you can differentiate, right?
Yes, sir.
So now the next one is some rules like if you have a constant y is equal to c times x power n, right? Correct.
Yes, sir.
Or c times f of x. Let's not focus on one particular function. In general, if it is c into f of x, right? What is the dy by dx, right? Okay.
Yes, sir.
Where c is a constant, c is some number. Okay. So again, I will follow my limit method and I will say limit of h tends to 0. Instead of in place of y, I have to put x plus h, right? Correct.
Yes, sir.
So it will be c f of x plus h, right? Minus c into f of x by h, right?
Yes, sir.
Are you understanding what is happening here?
It's the same thing, but you just substituted with h.
But basically this is my new function g, right? G is called c f of x, right?
Yes, sir.
G of x is called that, right?
Yes, sir.
And in g of x, I have to actually to take a derivative of g, I have to g of x plus h I have to do, right? Minus
Yes,
g
sir.
of x. So if I do that, it will become c times f of x plus h, right?
Yes, sir.
So now notice that C can come out of this, and this becomes the same thing, right? Limit x tends to 0, f of x plus h minus f of x by h, right?
Yes, sir.
And that is called the derivative of f, right? F dash x, right?
Yes, sir.
So basically a constant, if you multiply a constant, the constant doesn't affect the derivative, okay? So constant just remains multiplied, right, in the answer also.
Yes, sir.
So that is a general rule, because of which now you will be able to say what is the, if my function is 2x cube, what is the dy by dx, right? So 2 is a multiplied thing, x cube is what we know how to differentiate, right?
Yes, sir.
2 is a constant, so 2 remains, and x cube differentiation is 3x square. So answer will be 6x square, right?
Yes, sir.
So this rule is useful because this rule helps us avoid doing the limit just because it is a slightly different looking function, right?
Yes, sir.
We don't have to do the limit thing all the time, okay? Because we know that constants don't matter, it just keeps getting multiplied,
Yes, sir.
correct? Similarly, I can prove that if y is equal to fx plus g of x, right, then dy by dx would simply be f dash x plus g dash x. Okay, I will not prove this, this is very straightforward, so I will not prove this, but you have to believe it that this works. How would you do it? You will just take, let's say this thing is called a new function called t of x, right? T of x is f of x plus g of x, right?
Yes, sir.
So to find the derivative of this t of x, what do I have to do? I have to do limit of h tends to 0, t of x plus h minus t of x by h, right? Are you understanding what I'm
Yes, sir.
saying, or is there some confusion right now?
No, I've gotten it.
Okay, so t of x plus h will be what? F of x plus h plus g of x plus h, right? Minus t of x will be what? F of x minus g of x, right?
Yes, sir. By
By h. And this is limit h tends to 0, right? So now
yes, sir.
I will intelligently separate it. I will collect this and this together. So I'll make it f of x plus h minus f of x by h plus g of x plus h minus g of x by h, right?
Yes, sir.
Limit h tends to 0. And notice that this is the f dash x and this is the g dash x, right?
Yes, sir.
So you're getting t dash x is coming out to be f dash x plus g dash x, right? So sum or difference, these types of things don't change much. So if the function is a sum or difference of two functions, then the derivative is also sum or difference of those two derivatives, right?
Yes, sir.
So this is useful because now you can differentiate polynomials. Okay. Suppose y was this, right? Now dy by dx, earlier you didn't know what to do. You might have had to do the limit definition on the whole thing. But now, because you know that sum and difference doesn't matter, it's very obvious thing. So then you just differentiate each of them and just plus minus keep adding those, right? You understand?
Yes, sir.
So differentiation of x cube is what? 3x square, right?
Yes, sir.
3x square, and there is a minus, so I'll put a minus, and this is what differentiation 2x,
2x
and plus,
plus
and
0.
differentiation of constant is 0 because constant function never changes, right?
Yes, sir.
So slope is 0 here, right? So answer will be 3x square minus 2x. So the process of my differentiation has become very fast. It would have been much longer if I had to take limit here. Okay,
Yes, sir.
you understand? So if you know one standard formula and some standard rules, right, like this, then
And
your
what is
process
f dash? So what do you mean by dash? Like what are you taking as dash?
f dash means derivative only. That's why I said earlier that it's just a symbol for derivative.
Okay, yes, sir.
I said no, that dy by dx, it can write it like this. You can write it as f dash x. You can say it is slope of tangent. All of it means the same thing.
Yes, sir.
All of it means this only. 1 time dash means one derivative. 2 times dash means take another derivative. Differentiate once more.
Yes, sir.
It's all just same symbols. This would have been there in chapter 1, no? Chapter 2 or something if you had seen Thomas and Finney.
Yes, sir. 2, I think.
Okay. Now we are going to think about if some function is a product of two functions. Okay. Now what will we do? You have to do h dash x or derivative of h, right? Correct.
Yes,
Now
sir.
it's a product of two functions. So for example, it could have been question could have been y is equal to x cube into 1 plus x square, right? Something like this, where this is
Yes,
1
sir.
and this is the second function, right? Now how do I differentiate it? Okay. So again, we will learn a nice rule here. So if it is a product of two functions, the derivative will become differentiate one function and keep the other one as it is, plus differentiate the other function and keep the first one as it is. Okay. You
Yes,
understand
sir.
what is happening here?
Yes,
First,
sir.
you are differentiating f, keeping this one as it is, plus you are differentiating g, keeping f as it is, right? So here, my answer should be according to that rule. Let's do that. So first I differentiate this one. So what is that? 3x square, and keep it as it is, right? This one, correct?
Yes, sir.
Then I keep this one as it is and differentiate this one. So differentiation of this is by sum of multiple functions. So 0 plus 1 plus 2x, right?
Yes, sir.
So now if I simplify it a little bit, this becomes 3x power 4 plus 3x cube plus 3x square plus this is x cube plus 2x power 4, right? So it is coming out to be what? It is coming out 5x power 4 plus 4x power 3, right? This and this plus 3x square, right?
Yes, sir.
This is my differentiation, right? Y dash. Okay. So how can we confirm whether this is true or not? We can confirm it and say whether our rule is working or not, because right now I could have simplified this in a different way. I could have multiplied it out, no? Y is what? X cube plus x power 4 plus x power 5, right?
Yes, sir.
Can you see that I could have multiplied it out?
Yes, sir.
So now if I did it directly here, y dash, right? What is coming here? 3x square plus 4x cube plus 5x power 4. Is it coming?
Yes, sir.
What rule are we using? X power n is n x n minus 1, right?
Yes.
Derivative. Correct? Okay. Are you getting what happened?
So you directly multiplied with x cube, right? Like x
Ah,
cube with all the terms.
yeah,
So
yeah.
you got x cube plus x power 4 plus x power 5.
And then I
And then you
differentiated this.
applied the same rule.
Yeah. Or, and now because the answer matched, right? Then
Yes.
now we know that our method is correct, right?
Yes, sir.
Obviously, here I would not actually do it like this, but I'm just showing you to show the method. I would actually always do it like this, right? This is faster.
Yes, sir.
Okay. But that proves that the formula that we have written here is correct, right? At least it is working in this case. The proof is something else. So proof, let's do. So suppose hx is equal to fx into gx, right? Now I have to find h dash x, right? H dash x means limit of, actually I should have called it t or something. So now I'll write it as here, I will write t. T tends to 0. H of x plus t minus h of x by t, right? You
Yes, sir.
understand what I'm doing? I'm writing basic definition of derivative, right?
So it's t of x, right? You've taken.
No, I've taken h of x. No,
Okay. Yes, sir.
I've changed the variable here because h and h are clashing.
Got it. Got it.
If I had taken it as t of x, I would have written normally the h thing that I write, right?
Yes, sir.
Don't get confused by small things like that, right? You got it right now, no?
Yes, I have understood.
So h dash x will be equal to, in this case now, h of x plus t will be the product, right? And I will put this here. So if h of x was fx gx, h of x plus t will be what? F of x plus t g of x plus t, right? Minus f of x g of x, right?
Yes, sir.
I'm just putting in as input x plus t instead of x, right?
Yes, sir.
So I should get f of x plus t g of x plus t minus f of x g of x, right?
Yes, sir.
Okay. Now, right now there seems like there is no way to do this. Like it seems very weird. So what I will do here, I have to calculate this limit. So what I will do here is I will do a clever trick. So pay attention. F of x plus t, g of x plus t, I will subtract f of x, g of x plus t, and then add it again.
Yes, sir.
What have I done? I have not done anything special.
You just added and subtracted the same thing.
I have added and subtracted the same thing. The other two terms are unchanged, this and this. And but this is a nice trick because this helps us do this. So limit of t tends to 0. Here I can take g of x plus t common between these two, right?
Yes, sir.
G of x plus t common between these two. So what do I get? F of x plus t minus f of x, right? And in the second one, what can I take common? F of x I can take common, no?
Yes, sir.
Like this and this. So
Yes.
it becomes g of x plus t
Minus G of
minus g
X.
of x. And the whole thing is divided by t, right? Right.
Yes, sir.
Now, why is that useful? Because now this big numerator, I can split it into two separate fractions, no? This
Yes, sir.
by t and this by t, right?
Yes, sir.
Right. And notice that if you do limit t tends to 0, this by t, this part is what? This part is f dash x, no? Think about that is the definition of f dash x, right? Limit t tends to 0, f of x plus t
Yes,
minus f
sir.
of x by t, right?
Yes, sir.
And this part is again g dash x, right? Right?
Yes, sir. Yes, sir.
If it is limit t tends to 0. And
Yes, sir.
notice if you put t tends to 0, this becomes what? Simply g of x. 1 second, just hold on. Hello?
Yes, sir.
So you are understanding what is going on?
Yes, sir.
So
So till
basically,
you made it f of f dash x and g dash x.
correct. And this is gx and f dash x plus this is fx into g dash x, right? This one.
Yes, sir.
So that is what I wanted to prove. No, that was the rule that I was saying, right?
Yes, sir.
So that rule helps you now differentiate many things. Okay. So for example, this is product rule is super important. Product rule that we have just now learned. Okay. So I will be able to differentiate things like x cube into Right now, since I don't know any other function, so it's always a polynomial only that I can make for you. But so for example, obviously this is very trivial, so I will not do these examples. What I will show you now is sin x and cos x, okay?
Yes, sir.
Trigonometric functions. So how do you do differentiation of trigonometric functions, right? So think about y is equal to sin x and y is equal to cos x, and try for yourself how to do a derivative of this. So same method again, okay? Okay. Try for
Yes,
yourself.
sir.
I'll be back. sorry. Okay, sin x and cos x. Okay, so now we get to the interesting part. Are you there?
Yes, I'm there.
Yeah. So okay, so derivatives of sin x and cos x. So sin x, you know how the function is, right? So we have just started doing trigonometry where you know sin x can take any value and all. And the graph of sin x, if you want, you can draw. So this is y and this is x, and this is 0, and this is pi, and this is 2 pi, right? So at pi by 2, sin x takes its maximum value, which is 1, right? You know this much, that's till 180, you know these values, sine is positive, right, in first two quadrants. And after that, it will become negative like this.
Hello.
Hello? Yeah.
Yes, I
So,
got dropped out.
yeah. So right now I'm drawing the graph of sin x. Okay. So we are drawing the graph in this way that, see, 90 degree sine pi by 2, it is 1, right? At 0, it is 0.
Yes, sir.
And at pi, which is 180 degree, it is 1, it is 0, right? Correct.
Yes, sir.
You know all of these values also. And we know that third and fourth quadrant sine is negative. So see, 180 to 368 will be like this.
Yes, sir.
And then it will keep repeating. This is your sin x curve. It
Yes,
is
sir.
forever repeating like this. Okay. So if I want to find derivative, basically at any point x, I want slope of tangent, right? At
Yes,
any
sir.
point x, I want slope of tangent. Okay. So again, the derivative will come by the same method, limit of h tends to 0, f of x plus h minus f of x by h. So now what do we do for this? Limit of h tends to 0. This is what? Sin x is my function, right? So this
Yes,
will
sir.
become sine of x plus h
Minus
minus
sine of x by
sin x by h, right?
yes, sir.
Now, this is why you need maths a little bit for physics also, because derivatives right now we are doing, but we need a little bit of trigonometry now. So in chapter number 7 and 8, right, in SL Loni,
Yes, sir.
right now we are on chapter number 6. Okay. So in chapter 7 and 8, you will learn these formulas that if you have sine of a plus b, that will be equal to sine a cos b plus cos a sine
Say
b.
sine b. Yes.
Okay. So this is coming soon for you in trigonometry. So right now we'll use those formulas. And in chapter 7 or chapter 8, you'll also see this formula. Sine of c minus sine of d will be 2 times sine c minus d by 2 cos c plus d by 2, right?
Yes, sir.
Okay. So if we do that here, so this is some c and this is some d, right? Correct.
Yes, sir.
So if I do that here, so I will get 2 times sine of c minus d, that will be just h, so h by 2, and cos of this plus this by 2, so that will be 2x plus h by 2, right?
Yes, sir.
These formulas you'll have to trust right now. Next chapter in trigonometry, you'll know the proof. Okay. So we will do it very soon, so don't worry about it. Divided by h, right? Correct.
Yes, sir.
This is my expression right now. Okay. So what do I do now? See, the part here that is annoying is the part that contains the sine h by 2 divided by h by 2. You can bring this 2 down, no? And write it like this.
Yes, sir.
And the other part is not so annoying actually. This part, you could have directly put h in this part and it would give an answer, right? It will be cos of 2x plus 0 by 2, right?
Yes, sir.
So that is simply cos of x, right? So the only problem is this portion of the limit, right?
Yes, sir.
Because there is a denominator 0 here, right? Correct.
Yes, sir.
Now in limits chapter, in the limits chapter in Thomas and Finney also, he will show you that limit of x tends to 0, sin x by x is equal to 1. Have we discussed this limit yet? No, right?
No, sir.
Okay, so we will discuss this limit, and also tan x by x is equal to also 1. So first of all, assume that this is true. Then see here, if h tends to 0, this part is h by 2, that also tends to 0, right?
Yes, sir.
And that angle is being matched here, right? They're the same thing, h by 2 and h by 2, right?
Yes.
So this is of the same form, right? Limit x tends to 0, sin x by x. If that is 1, then this should also be 1, no?
So could you repeat that? If what?
If this limit is 1, if this
Yes,
limit
sir.
is 1, then this limit should also be 1, no?
Yes, sir.
Because limit h tends to 0 means h by 2 tends to 0 also, right?
Yes, sir.
So it is exactly same thing, no?
Yes, sir.
So assume that this is true for now. We'll prove it just now after this. If this is true, then this becomes 1 and this becomes cos of 2x by 2, so cos of x, right?
Yes, sir.
That is your answer for derivative. That is the correct answer. So derivative of sine of x is cos of x. Dy by dx is equal to cos x. So the proof involves a little bit of trigonometry, one formula here, and knowledge of this particular limit, right?
Yes, sir.
So let's prove this limit. We have to prove that limit x tends to 0, sin x by x is equal to limit x tends to 0, tan x by x. That also is equal to 1. Okay. Both of these things are equal to 1. Now, how do we prove this? Right now, what we'll do is we'll prove it by geometry. So for example, I will take a circle. I will take a circle, and this circle has radius equal to 1. Radius is 1 on this circle, okay?
Yes, sir.
So this is my x-axis, this is my y-axis, this is a point P, this is a origin, okay? So uh, let's take one line like this. This line has length 1, right?
Yes, sir.
And this point is here. This is also, so let's say Q, and join this, okay? Okay, I should have drawn a bigger circle. 1 second. I should have drawn a bigger circle here. Let's say this is my circle, and let's say this is my point P, O, Q. I'm joining P and Q. I'm also extending this like this. And from here, I'm drawing a line 90° to it, and that will cut here at R. What am I saying here? This is 90, okay? Okay.
Yes.
So what have I done? I have taken two different radiuses. One is OQ, one is OP. I have joined PQ. And then from Q, I have drawn a perpendicular line perpendicular to OQ or x-axis, and that cuts the OP line at R. Okay, makes sense
Yes.
the diagram? The
Yes, sir.
radius is 1, the radius is 1. So this is 1, this is 1. Okay.
Yes, sir.
Now, let's say this angle is some x. Okay. This angle is x. X is written in radian. X is written in radians. Now, uh, now think about what is the area of triangle? Area triangle OPQ. Okay. Area triangle OPQ. You can see the triangle, no?
Yes, sir.
So it will be half base into height, right?
Yes, sir.
So let's draw a height here, right? This height, let's say it is S here, height PS. height PS will be, what will be the length of PS? We can make a right angle triangle here and think about it as sine x, right? So
Yes.
sine x is what? Sine x is PS by OP, right?
Yes, sir.
Correct.
Yes, sir.
It is x by 1. Put it down and close the door. Why? Sine x is x by 1, no?
Yes, sir.
So this height is PS. You realize that?
Yes, sir.
Okay. Then area of the triangle OPQ will be what? Half into 1 into x, no?
Yes, sir.
Okay. What is the area of triangle? Area triangle ORQ. ORQ. Okay. So in triangle ORQ, what is RQ? RQ is anyway perpendicular, no?
Yes, sir.
So how will you write RQ here? Think about the ratio tan x. Tan x is what? RQ by OQ.
By okay. Yes, sir.
And OQ is 1, no?
Yes, sir.
So RQ is simply tan x. Basically, I'm saying this ratio is tan x and this height was sin x, right?
Yes, sir.
So area of triangle ORQ is what? Half into base is OQ and RQ is tan x, right?
Yes, sir.
So, okay, here I have made a mistake. PS was sin x, no? What am I doing? PS was sin x, I think, right? Correct. This is not area half into 1 into x, it's not half into 1 into sin x, no?
Yes, sir.
So you should point such errors out, no? What are you saying? Yes, yes, you're saying. How did you say that it is half into 1 into x? How did you agree, dude? I was careless. Area
I
of
was
OP.
writing.
Why are you writing? Don't write all of this. Pay attention. I'm recording all the classes, dude. You can watch it again.
Okay, yes, sir.
You can watch it and you can see it. I will put it up and you can see it. Don't write. Just pay attention and make sure that you understand and spot errors and all.
Yes.
Because if I'm also making a mistake and you are also blindly following, that is not a great sign, right? So
Yes,
area
sir.
triangle OPQ is simply half into 1 into sin x. That is the correct expression. Because PS is sin x, 1 is the base, right?
Yes, sir.
And area ORQ is half into 1 into tan x, right?
Yes, sir.
Okay. What is the area of sector? Sector OPQ. Do you know what the meaning of a sector is?
Yes, sir.
Sector is this portion of the
The
circle
whole
till
area.
here, right?
Yes,
Till
sir.
here. So that sector area will clearly depend on the angle that it makes at the center, right?
Yes, sir.
So I will write it like this: x by 2 pi into pi r square. You understand why this is correct? Pi r square would have been total area of the full circle, right?
Yes, sir.
And x by 2 pi tells you what fraction of the circle this sector is in, right? Like if it was 90-degree, it would have been 1/4 of a circle, no?
Yes, sir.
If it was 60-degree, it is 1/6 of a circle. If it is x radian, it is x by 2 pi fraction of the circle, right?
Yes, sir. Yes, I got it.
So this is my sector area. So x by 2 into r square, and r is 1, right? Right?
Yes, sir.
So area of sector OPQ is x by 2. So now we have done three different areas we have found out. And what we have realized here is that one area is inner triangle area is sin x by 2, other area is x by 2, the sector area, and the outer triangle area is tan x by 2, right?
Yes, sir.
Right. Now you can easily see, obviously, by the diagram itself, it is clear that triangle OPQ area is less than sector OPQ area and is less than ORQ triangle area, right?
Yes, sir.
That is obvious.
Yes,
That
sir,
is
it is.
obvious, no? So basically you can say sin x by 2 is less than x by 2 is less than tan x by 2.
Yes, sir.
Okay, so cancel the 2's off. You get sin x is less than x is less than tan x,
Yes,
right?
sir.
Divide by x. Sin x by x is less than 1 is less than tan x by x, right?
Yes, sir.
Now take limit x tends to 0. Now think about what happens if x tends to 0, right? Now as you make x tends to 0, what happens is all the three areas will become closer and closer. Can you see?
Yes,
Like
sir.
if my angle was really small, I'll draw a tiny circle here, and if my angle was really small, can you notice any difference between the three areas? Not much, right?
Yes, sir.
The difference will be very obvious if the angle is big, right?
Yes, sir.
But as it becomes smaller and smaller, all three areas will become almost same, right?
Yes, sir.
So that is obvious from the figure. So convince yourself that it is making sense for you, right?
Yes,
if
sir, it is.
if the angle comes down, right, comes very close to OQ line, then each area is very similar, right? All three, right?
Yes, sir.
So in the limit x tends to 0, sin x by x will tend to 1 and tan x by x will also tend to 1 in the limit x tends to 0.
Yes, sir.
They will tend to 1 from opposite sides, however, right? Like because actually this is lesser than 1 and this is greater than 1, right?
Yes, sir.
So this will be say 1.001 and this will be 0.999 or something like that, right?
Yes, sir.
So this will be also tending to 1 and this will be also tending to 1, but from different sides, right?
Yes, sir.
So that is a geometrical proof that limit x tends to 0, sin x by x is equal to 1 is equal to limit x tends to 0, tan x by x. Okay.
Yes, sir.
Now
Understood.
these two limits are super important. These two limits are super important while doing derivatives. Okay. So or while doing any other limit calculation, you need to know that this limit tends to 1. So what is important here is to notice that the angle has to become really small first of all, and x and x should match. Okay, it should not be like this: sine 2x by 3x limit x tends to 0. This is not equal to 1. So here x tends to 0, 2x definitely tends to 0, 3x also tends to 0, but the angles are not matching, right?
Yes, sir.
So what you have to do here is to calculate this limit. You can do this: limit x tends to 0 sine 2x by, write 3x as 2x into 3 by 2, right?
Yes, sir.
It is the same thing, no? Correct. And now what you can say is that in this case, this angle is matching this angle, right?
Yes, sir.
And both of it is tending to 0, right? So now it is
Yes, sir.
similar to the form that I know. Okay. So now this part will tend to 1, just like this.
Yes, sir.
So this part tends to 1 and the overall limit is definitely tending to 2 by 3, no?
Yes, sir.
So the answer here is 2 by 3 and not 1, right? So you have to be
Yes.
slightly careful in such questions. So for example, in the sin x differentiation example that we were doing, right? Dy by dx of sin x, right? So we got 2 times sine h by 2 cos 2x plus h by 2 by h, right? Limit h tends to 0. This is what we got, okay?
Yes,
Now,
sir.
uh, that this is the reason that I brought the 2 down, okay? Why did I bring the 2 down? So that I can match this and this.
Yes, sir.
Because it was matching, that's why I could say that this is equal to 1, because both are tending to 0.
Yes, sir.
And then you got the answer as cos x, right?
Yes, sir.
So now that you know cos x, you can do sin x derivative, cos x derivative also. Right now you know sin x derivative is cos x. Let's do cos x derivative. So cos x derivative will be dy by dx will come out to be minus sin x. How will it come out to be that? Again, same thing. You need a little bit of trigonometry again. Cos x plus h minus cos of x by h, right? So
Yes,
this
sir.
is cos c minus cos t. I know the formula. You will also know it soon. I'll just write it here. It will be 2 sine c plus d by 2. So it is 2x plus h by 2 into sine d minus c by 2. And d minus c will be x minus x plus h by 2. Okay. So this becomes 2 sine x plus h by 2. And this becomes x minus h by 2. Sine of minus h by 2, right?
Yes,
By
sir.
h. Now sine of minus x you have learned is minus sine x, right?
Yes, sir.
We saw that yesterday, I think.
Yes, sir. Yes.
So it becomes minus 2 sine x plus h by 2 into sine h by 2 by h, right? Now notice that I can bring the 2 down again here, right? And therefore this matches now. This matches the form that we have just now learned, right?
Yes, sir.
Because limit h tends to 0, the angles are tending to 0 and the x and x are matching here, no?
Yes, sir.
So this will become 1. And what will be left now? Limit h tends to 0 minus of sine x plus h by 2, right? So when
Yes.
you put h is 0 in here, it comes as minus sine x, which is what you have to remember. If y is equal to cos x, dy by dx becomes minus sine x, right?
Yes.
So now that you know trigonometric functions also, now what we have to do is tan x, okay? One trigonometric function that is left is tan x, no?
Yes, sir.
So tan x is sin x by cos x, right? Now I'll not do it by the limit method, okay? Now I'll use some knowledge that I have acquired today. So today I have learned that product rule happens, right?
Yes, sir.
Product rule can happen, and product rule, I know what to do. I know if I have to differentiate this, I have to do f dash x g of x plus fx g dash x, right? Correct.
Yes, sir.
Okay, great. So here, okay, it will involve something that I have not told you, but uh, I'll just show you anyway. So here it is a division, no, it's not a product, no, right now.
Yes, sir.
So division can be thought of as a product, okay? Division is a product of these two functions,
Yes, sir.
right? So I will do it now. By product rule, I will do it. This is my f, this is my g, okay? So differentiation will be, differentiation of sin x is cos x, and keep the other one as it is, right? Correct?
Yes, sir.
Plus keep the first one as it is and differentiate this one, right? So think about how to differentiate 1 by cos x, right? This is basically sec fx, right? Correct. So we have to differentiate this, no?
Yes, sir.
Actually, I have not taught you this part. This is actually chain rule. So uh, chain rule says that if you have y is equal to f of g of x, right? What is the meaning of this? This is called a composite function. Composite function means if I take an input x, I am giving the input x to g function, and whatever is the output of g function is being fed into another f function. You
Yes, sir.
understand?
So G is first, right?
G is first. So basically, you take an x. This is a g machine, right?
Yes, sir.
It gives an output g of x. And this output is fed to an f machine, and that gives an output f of g of x, right?
Yes.
So notice that if you are doing 1 by cos x, right? Correct. So
Yes, sir.
technically, what are you doing? You are doing two things actually. You are doing cos x and you are also doing reciprocal, no? Right? 1 by cos x is two things, doing two things. First, it is doing cos x, then it is taking reciprocal, right?
Yes, sir.
So it can be thought of as f of g of x, where f of x is doing reciprocal and g of x is doing cos x, right? So give an input of x, then g of x becomes cos x. So this becomes f of cos x. And then f does what? It does reciprocal, right?
Yes, sir.
So technically 1 by cos x is not one function. It is two functions linked together, right?
Yes, sir.
You understand what is happening?
Yes, sir. You broke it up basically. No?
Basically, it is two parts. There is first, there is cos x you are doing, and then out of that, the output that comes, you're doing 1 by cos x, right?
Yes, sir.
1 by of that. So whenever you have a composite function like this, where there are two things mixed together, right? So the derivative is done in this way. uh, y is equal to f of g of x. If I have to differentiate this, right, with respect to x, then first I will do f dash of g of x. So I will ignore that inside part is itself a function, and I will do differentiation as if it was just f, right? F dash g of x, and then I'll multiply differentiation of the inside part. So I will give you some examples. So let's take some simple examples. Y is equal to sine of x square. Okay,
Yes, sir.
correct. So this is clearly two functions. No, one is a sine function and one is an x square function, right?
Yes, sir.
So if I have to differentiate this, the inside part first I will ignore. I'll differentiate this outside part. So sine differentiation should be cos, right?
Yes, sir.
And ignoring inside part, so I'll keep it as it is, right? Cos of x square.
Yes, sir.
And then now multiply it by differentiation of the inside part. So that is x square, so 2x. Okay.
Yes. So is that the final like output?
Yeah, that will be the final answer. We can prove this also, but proving this by limit method will be slightly long. So I'm not showing it to you right now. I'm just
Yes,
telling
sir.
you how to do it. But it is very obvious how to prove it also. You can do the, if you know a little bit of trigonometry, the saying in sine C minus sine D stuff you will do, it will come. Okay.
Yes, sir.
So if you have doubts, you should try to prove it, but later I will show you anyway. So it's fine. Uh, Another example, for example, suppose y is equal to sine of x plus x square plus, okay, that's the same thing almost. So what is the point, right? Okay, I'll do a slightly more difficult one. Sine of cos of x, right? Now it is clearly two functions are mixed, right?
Yes, sir.
So what do I do now? To differentiate this, I do outside part
Cos.
difference. Cos
Cos
of
into cos x.
cos x.
Cos of cos.
No, it is not cos into.
Yes, sir. Of
It is cos of cos x, and then do the inside part, minus sin x.
minus sin x.
So that is the way you differentiate when it is like this, right? So now
Yes, sir.
get back to the original one. So let's say we have 1 by cos x, right? So you can think of this as cos x to the power minus 1, right?
Yes, sir.
So now my inside part is not x. If inside part was simply x power minus 1, then it is not composite function. Then it is a straightforward function, right?
Yes, sir.
Inside it is itself cos x. So it is, that's why it is a composite one. So if I want to differentiate y dash, I will first think of this, ignore the fact that it is cos x, and do it what it will happen if you do x power minus 1, or right? So that will be minus 1 cos x to the power minus 1 minus 1 by the rule. By what rule? X power n becomes what? N x n
By
minus
x n
1. No.
minus 1.
So minus 1 comes outside, and cos
Yes,
x
sir.
minus 1, right?
Yes, sir.
And then I realize that inside is not x, so cos x also have to do, so that is minus
Minus
sin
sin.
x. So the differentiation of this becomes sin x minus minus by cos square x, right? Correct? Because this is
Yes.
cos x power minus 2, no?
Yes,
So
sir.
this becomes sin x by cos x into 1 by cos x, right? So that is actually sec of x tan of x, right?
Yes, sir.
So right now I have learned that if y was equal to sec of x, differentiation is sec x tan x. Okay. But
Yes.
notice that it comes by a complicated method. It's not so straightforward, right? It comes by the f of g of x. It's a composite function, so you have to be a little careful here how it comes, right?
Yes, sir.
See, all of these ones we can do by the limit method, but limit method is not very practical because you'll not always be doing limits. Okay. So that's why now
Yes.
we are going over to the rules of derivatives, right? And we are not
Yes.
doing it by the limit method, we are doing it by rules of derivatives. So now my original question was, if y is equal to tan x, how to do it, right? So now we can do it because it is sin x by cos x, right? And it is sin x into 1 by
1 by
cos
cos
x.
x.
So it is a product of two functions, sin x and sec of x, right?
Yes, sir.
Now I will do it very easily because now I know derivative of sec x, right? So
Yes.
now I'll do sin x differentiation is cos
Cos
x
x.
into sec x plus keep the sin x as it is and differentiate this, we know is sec x tan x, right?
Yes, sir.
So cos x into sec x is 1 plus sin x, this is by cos x into tan x, right? Correct.
Yes,
And
sir.
this is tan x only, right?
Yes,
So it is
sir.
1 plus tan square x, that is
Yes.
equal to secant square x.
Yes, sir.
So derivative of tan x, d by dx of tan x comes out to be secant square x. Okay.
Yes, sir. I understood.
So now you know sin x, cos x, tan x. You should be able to yourself now do everything. So for example, if I asked you cosec x, right? So think of it in the same way that I did sec x, right? So it is 1 by sin x, right? So it is sin x to the power minus 1, right?
Yes.
So do it by the chain rule that we have just now learned. Forget that this is sin x for a moment. So what will you do? Minus 1 sin x to the power minus 1, and
Yes.
then do the inside part. So that is cos x, right?
Yes, sir.
Differentiation of the sin x inside, right?
Yes, sir.
So this will become minus cos x by sin square
Sin
x.
square x.
So this is actually minus cosec x cot x, right? Correct.
Yes, sir.
Makes sense, no? And if you do cot x, you should verify for yourself as dy by dx of cot x is minus cosec square x. Verify for yourself, it will come. How will you do it? Do it by the product rule like this, right? Correct.
Yes, sir.
Are you understanding or are you saying yes?
I understood till dy by dx is minus cos x square x.
No, this how have you? This I'm asking you to prove. So
I
you
mean the
need to
previous one.
this
Minus
one you
cosec x
understand. No?
cot. Yes, sir.
Now I am saying how to do cot x, right? Just now we did tan x, no? The only
Yes, sir.
difference
Yes,
in
sir.
tan x was sin x by cos x. Now it is cos x by sin x, right?
Yes, sir. So cos x into 1 by
Cosec
sin
x, right?
x. Yes, sir.
So now you can do by product rule, no? Because you know both. You know cosec x differentiation is this, right?
Yes, sir.
And you know cos x is minus sin x, right?
Yes, sir.
Then using that, you should be able to prove that it comes to be this.
Yes, sir.
Okay.
Got it. Yes, sir.
Okay. One more thing I wanted to mention. One second. So these derivatives we have seen. Oh yeah, one thing that I wanted to mention was now quotient rule. Okay, there is a quotient rule also. This quotient rule, sometimes people ask you to remember stuff here. So for example, when you start doing your classes in Allen, they will ask you to remember it like this: f dash x g of x minus fx g dash x by g of x whole square. That is your y dash. Now this is sometimes hard for people to remember in the beginning. This is quotient rule. So right now we knew product rule, no?
Yes, sir.
If fx into gx, then derivative is simple: f dash x gx plus fx g dash x, right?
Yes,
But
sir.
this quotient rule is slightly annoying to see. Like this is looking weird, right? Correct.
Yes, sir.
So if it was fx by gx, this is a standard formula. This is a correct formula. This will give you the answer, but it is difficult to remember. So now you can realize why the quotient rule is like this. The reason is that think about quotient rule as product rule only,
1 by j.
correct?
Yes, sir.
Think of this as product rule only. And now if I do f dash, so I have to differentiate first one and keep the second one as it is for now, right? And
Yes,
then I
sir.
have to keep the first one and differentiate the second one, right? And differentiating the second one is a composite function, no? Chain rule, right?
Yes, sir.
You understand this part,
Yes, sir.
that this differentiation would be, first do it as if it's a power, minus 1 gx to the power minus 1
Minus
minus
1
1,
minus 1.
and then do inside part, right?
Yes, sir.
So now if you simplify this, see what comes: fx f dash x by g of x here, and this becomes minus fx by g of x whole square, right, into g dash x, right? Correct.
Yes, sir.
And see, isn't that the same thing? Make it square here and write it to gfx here, right?
Yes, sir.
See this?
Okay, yes, sir.
That is the same thing. Okay, so this quotient rule can come by the product rule method that you have been using. Okay, however, it is sometimes convenient to remember this also directly. You don't need to do this much, right?
Yes, sir.
You can just remember this formula and you'll get the answer. What we have done today is differentiation in all its ways, like how to differentiate. Many of the standard differentiations we have seen. What you need to do is today and tomorrow itself, go to chapter 2, chapter 1, do enough questions from both. By enough questions, I mean enough questions so that you gain the confidence that you can do it yourself.
Yes, sir.
You understand? There is no lower limit or upper limit. I'm not saying do every question in the exercise. I'm saying do enough so that you feel like I am getting it now,
Yes, sir.
right? Because
So for both limits and differentiation, right?
chapter 1 and chapter 2, enough questions in both.
What about the previous and the preliminaries?
If you feel like you don't get it, do it. Like do whatever feels difficult to. Like
Okay,
if it
yes, sir.
feels like you're not getting those questions, then you have to do it. No, then.
Yes, sir. Yes, sir.
So it's a straightforward process. The process is that you have to learn whatever needs to be done, you have to do, right? So if chapter 0 is not happening, then you have to solve it. If chapter 1 you're facing issues, try it. Try as much as you can chapter 1 and chapter 2. Next week's class for math, for physics, what we will be doing is chapter 3 and chapter 4 ideally. But I will be asking you whether you got stuff from 1 and 2, and it will be very obvious to me if you have not gotten it, right?
Yes, sir.
It will be
So
very obvious.
tomorrow is chemistry, right?
Yeah, tomorrow is chemistry.
Sir, but could you keep it in the morning because I have Alan in the evening?
Okay. uh, I will schedule it in the morning sometime. That's fine.
Okay, yes, sir. Thank you, sir.
Uh, but uh, pay attention to the part. You have to do stuff in 1 and 2. Okay.
Yes, I'll do it.
And see, if you don't do it right now, no, it will get stuck and you will not know what to do here, and then we'll move on. I will not be able to spend too much time on this right now. Okay. So there is only 1 or 2 more weeks of calculus that will happen before we have to actually start the physics part, right?
Yes, sir.
Because this is the physics class, but we are actually doing maths because it is important.
Yes, sir.
Everywhere else we'll be using it. So it is on you to spend enough time doing chapter 1 and chapter 2. Forget about what Alan homework is coming and all. Okay,
Okay, yes, sir.
don't worry about that. What we are doing is more important. Otherwise, for most students, what happens is the entire first year, entire 11th, they spend time just mugging up 10 formulas for differentiation, 10 formulas for integration. They don't understand anything, but they have mugged up the answers and they keep doing that. And many times they are completely clueless because they don't know what to do. Like if
Yes,
there's
sir.
a
I knew most of these rules, but I didn't know how to do them.
so don't be one of those people who are clueless for an entire year about what to do in calculus.
Yes,
Okay,
sir.
so that is why we are doing the Thomas and Finney textbook right away. Right now you have to sort out all the basic stuff, do enough small easy questions that you know confidently what to do, right?
Yes, sir.
So this week and next week's next 2-3 weeks are going to be super crucial for that, so make sure that you are paying attention to that. Okay,
Yes, sir. But the textbooks have some things like which we haven't covered. So do I do those also, or
do whatever we have covered.
okay, yes, sir.
Don't worry about whatever section we have not done, though the sections that you think we have done in our classes. Okay,
Yes, sir.
differentiation we have done, functions basics we have done, limits we have done basics,
Yes, sir.
calculation of limits we have done, sin x by x, tan x by x. We know how to calculate by cancelling some common factors and all. So chapter 1 and chapter 2, most of the things we have covered. If there are some tiny things that are left, that we will discuss it in the coming classes.
Yes, sir.
Okay, that's all for now. I'll tell you what time, around 10:30 I think will be fine for me.
Okay,
So
yes, sir.
okay, okay, bye.
Bye, sir.